Okay, we had opened up this section doing an activity called Reaching for the Beads, where we were able to kind of learn about what a sampling distribution is, and that is going to be the main focus of the second half of AP Statistics, is learning how useful a sampling distribution is. And so we just want to talk about a few terms here to kind of bring this first day to a close. This video will be rather short. The process of a statistical inference is anytime you're using information from a sample, but then you're trying to use the information from the sample to draw conclusions about a wider population. And we just always want to keep in mind that, every time you draw a random sample, they're each different, they're each unique, even if you've drawn it using a proper random process. And so you are going to get a slightly different statistic, a slightly different mean, or a slightly different sample proportion. This picture here kind of summarizes, actually these two pictures here, really kind of summarize what happens in statistics, where we're drawing a sample out of a larger population. We've collected a nice representative sample. Down here you can see this was our large population. We just want to make sure that when we're performing that random selection, that we are using the proper sampling techniques that we studied all the way back in chapter 4. Things like a simple random sample, a cluster sample, a stratified random sample. Never those convenience samples or things like that where we would introduce bias. Okay, and so here we've got our sample, and then we might, from that sample, we might find the mean, or we might find the sample proportion of something. That is our statistic. And then based on that statistic, we then come back and we draw an inference or a conclusion about that broader population. Okay, so we just want to make sure that we are comfortable with some of the terminology here that surrounds populations versus samples. When you see the word parameter, that is definitely describing a characteristic about a population. Okay. Typically, the value of a parameter is generally not something that is known, and for that reason, we really can't necessarily examine an entire population. So what generally happens in statistics is it is actually a statistic that we are analyzing, because that is a value or a number that is simply just describing a sample. Okay, and again, the value of that statistic, we compute that directly from the sample that we have drawn. And this is important, that we're using the statistic as an estimate to help us with an unknown parameter, something that we don't know about the population, but the statistic will help us try to figure something more about that. Okay. Now, it is very important that you understand the difference between the variables. On the AP test, they will undoubtedly take off if you misuse your variables and you're not using them for proper things here. So we know that when we talk about a statistic, we are talking about things describing samples, and when we talk about a parameter, we're talking about things that describe populations. Okay, so I just want to make sure there are generally two main things that we analyze about samples or populations, and those are typically either proportions or those are means. Okay, generally means are numerical. Proportions is when we are studying maybe a categorical piece of data, and so then we figure out what proportion of our sample said that they preferred oranges over apples, something like that. Okay, but do note the difference in the variables here. Just a plain P represents the proportion of the entire population, whereas a P hat represents a proportion of just your one sample. A mu symbol would be the mean of a population, and an X bar would be the mean of a sample. Okay. There are also different variables used here for a standard deviation, and that is this sigma symbol for a population standard deviation. A lone S, or sometimes it's written S sub X, could be the symbol for the standard deviation of just a sample. And so we're going to close this video out with just looking at two short examples here, comparing a parameter versus a statistic. We are asked in these examples to identify the population, the parameter of interest, the sample, and then the statistic in each of these following settings here. Okay, so it mentions that a pediatrician wants to know the 75th percentile for the distribution of heights of 10-year-old boys. So she takes a sample of 50 patients and she calculates the third quartile as being 56 inches. Okay, please keep in mind that when we are talking about the 75th percentile, that is whatever value, this we're talking about heights, whatever value here would hold 75% of all the other heights below it. Okay, and so it feels like the population here, this pediatrician is really just looking at those in her practice. So we would definitely say that this is probably a convenience sample, unfortunately. Okay, and so we would say this would be all 10-year-old boys in her practice. Okay, she didn't sample from all 10-year-old boys in the world, but rather just the 10-year-old boys that are in her practice. The parameter would be the true 75th percentile. Okay, referring to if we looked at all the 10-year-old boys in her practice and then we found what value the 75th percentile was, that would be the parameter. The sample is actually the 50 patients in her practice. Okay, and when I mention patients, maybe I should be specific and say 10-year-old boy patients. Okay, and the statistic here would be the third quartile of the sample, which was the 56 inches. Okay, so she took a sample of 50 patients, and she calculated just from that sample that the 75th percentile, or the third quartile here, is 56 inches. So that is the statistic. Okay, so we have to make sure that we're really comfortable when we read through a scenario like these two here, that we can identify each of these four different things. So here we say a Pew Research Center poll asked 1,102 12 to 17-year-olds in the U.S. if they have a cell phone. So this feels like the question is more a categorical variable than it is a quantitative variable. People's responses would have been a yes or no. So an indication of this is they're not averaging their responses. You cannot average words like yes or no. We're figuring out the proportion, kind of like in the beads activity that we had done at the opening of this lesson. We were trying to find what proportion of our sample was red beads. Here it's mentioning of those who responded, 71% of them said yes. So the population is whatever they drew the sample from. Like the previous example, that doctor drew her sample from 10-year-old boys in her practice. Here they would be drawing out from all 12 to 17-year-olds in the U.S. Okay, the parameter, we don't know what that is, but I'm just describing what it is. It would be the true or actual population proportion of those 12 to 17-year-olds owning a cell phone. Okay. Now, the sample is the 1,102 12 to 17-year-olds in the U.S. And the statistic, and here's where we have to be careful. I'm just going to draw your attention back up to the top of this notes page. When you are labeling these, okay, the statistic, make sure that you're using these variables, okay? We are talking about a proportion, but a statistic is a p-hat. That's a sample proportion, and that would have been the 71% of the 1,102 that were in the sample, okay, said that they own cell phones. Okay, that's going to bring this video to a close. Just a few problems here for you to go ahead and try, very similar to those